me?
Yes, I can hear you. Go ahead.
Okay, guys, welcome to our. Okay, so welcome to the class. Today we are going to continue with Python basics, and what we are going to be learning this week is loops, conditionals, functions, and classes. So today we'll start with loops, conditionals, and start with functions. So I think I have to stop sharing the screen. Share something else. Okay. So like most of the time, like all this while we've been learning, we've been looking at sequential, like codes that execute sequentially. But sometimes, not sometimes, most times in real life, we do not want to just, we want to execute some things based on certain conditions or based on a particular situation. And there are times we want to do some task again. That's where control structures come in. With control structures, you can tell Python the order of the order in which an instruction or the instructions in your code should be executed. So we're going to just start with like conditionals first. So there are times when you want a code to execute if a particular condition is true, and maybe execute something else if that condition is not met. So that's when we use conditional statements. Most of you already know like how this thing works. So for you to perform that kind of decision making in Python, you have to use the if conditional. So the syntax of the if statement is like this. So you use the keyword if, then you say you write an expression. So let's just do this. Let's just say this is an expression. So this expression here has to evaluate to either true or false. Happens, you should have like a statement here that will be executed. Like if this expression results into true or evaluates into a true value, the statement inside of this block is going to be executed. So let's just do this. Let's say if true. So this is like just this is always going to like if true is always going to like this is always going to evaluate into a true, because you have already like written a true value there. So this is going to be printed out if the expression is true. So we can think of an expression that is true, like let's say 3 is greater than 2, which is true. And then it prints that. But what if we say if, excuse me, you see that statement does not get executed. That is like the basic, like the most basic form of a conditional statement you can have, that you have in Python. So let's just like, I don't understand though. Can you all see my screen?
Yeah, we can see your screen.
Yes. Okay. All right. So let's just run a few more tests here. So we can have x is equal to 12 and y is equal to 3. So if you want to like write a conditional statement to evaluate a particular, to run a particular statement, if a value is correct, you start with the if keyword, then you put in your expression, say x is greater than y, then print let's just say yes. Then if y is greater than x, print no. Okay, so when you run these two statements, just one is going to get executed, because the condition, just one condition is met. So let's say if x is greater than y, this is going to resolve into a true value, while this is going to resolve into a false, and so the next is not going to be executed. I hope like that's clear to everyone. So if you remember, inside when you were first introduced to Python, you learned that Python, like indentation is very important in Python. So why it is much like very, very important is because, like, if you want to, let's say you want to execute multiple statements, if a particular condition is correct, you can inside of this if block here, you can write any amount of statements you want to execute. So anything inside of this block now is going to be executed. So like if you want a statement to be executed, if a particular expression is evaluated to true, you can just write as many statements as you want, like all compound statements here, and they will all get evaluated. But then if you make the mistake of putting it outside of the block, and this value executes to maybe false, this line of code is not going to be evaluated. So you should always like check your indentation. It could cause maybe a bug, and then you might be wondering, okay, why does this thing not run the way I want it to run? It's likely because your statement is outside of the block. So now we've seen how to like run like a basic if statement. You can write as many if statements you want inside of your Python code. But then you might say, okay, if a particular statement does not evaluate true, and you have another condition in mind, say in this our case, if y is greater than x, let me see how to put it. Okay, so let's say you want something to execute if a particular condition is not met, then you can use the else statement. So if x is greater than y, do this. Then you can use the else. That means if it does not evaluate to true, you should do this. So let's say x less than y, which is going to be false. And then you see that the else block is what is going to get executed. So it's like if this does not happen, I want you to do this alternative, follow this alternative route. So that's like using the else clause. So then there are times when like you have multiple conditions. Say, let me see. So let's say X is equal to name is equal to Kemi. And we want to print a particular value if the name is Kemi. Hopefully we're going to like be having other names, but then if the name is Kemi, we want it to print something, or if the name is something else, we want it to print another thing. We can just do if name is equal to Kemi, print my name is Kemi. So if you want it to print something else, if the name is equal to Chuka, you can use the elif clause. It's like else if name is equal to name is equal to Chuka, print my name is Chuka. And then you can add another elif. Say if name is equal to see print my name is Tracy. So like what if this whatever this evaluates to, either of these conditions are going to be executed. So if we run this, we're going to have this because name is equal to Kemi. But then if we change this value to Chuka, we'll have my name is Chuka running. Or if you change it to 30, then you have the next block running. So you can use like as many else if like elif clauses as many times as you want in your code. And then, but if you want your code to like run something, if none of those conditions are met, you can now add another. Maybe you can add an else statement. So, but like if you're adding an else if you're adding an else inside of this conditional, it has to be like the last. The else has to be the last. It has to be the last statement there. So let's see, else print no name. Since none of these conditions here match, like evaluate to true, it's going to print the last statement here, which is no name. So you cannot put your else statement before your elif. So if it's going to be inside of an if statement, it should be the last one there. It should be the last. Okay. So basically, the way if statements and elif clauses run is like it doesn't bother to, if a particular condition is true, it doesn't bother to run or even evaluate the remaining part of the code. So if it just matches one particular condition that's true, like it doesn't even, we are going to be even if you are going to put codes that maybe, even if you run codes that will not work on a normal day, if it matches any condition before it reaches that statement, Python is not going to like look at any of those other codes, the remaining conditions after the one that matches or evaluates to true. So that's just something you should note. So, but then if you might want to, there are times when you want to you have so many, like maybe so many, let's say you have so many maybe you have many conditions you want to test for. It's not really elegant for you to have like so many if statements inside of your code. So what you can do is you can use dictionaries. So if something evaluates to something, you can get the value attached to it. So you can put all of these names inside of, you can put all of these different names inside of a dictionary, like with maybe their names as keys, like Kemi, Chuka, Toyosi, and then you can have the value assigned to them as my name is Kemi, my name is Chuka, and my name is Toyosi. So you will just get a particular key, maybe get Kemi, and then the value is going to be my name is Kemi, instead of doing if. So that like make your code look better or stay elegant. So like you can also do a one-line if statement. So usually you should have, I'm sure you guys noticed the semicolon here, so it's very important. So you can have, usually if you want to have like a single if statement, you can just have this. But you can also just bring this one up here into a single line like this. So let's test it out, please. Okay, so that works. So you can just do this and it looks like cleaner. And also you can also like write an entire if statement. So we've seen like after having an if, let's see, after our if keyword, we have like if name, sorry, after the if keyword and the expression, we can have like a whole block of code to execute. We can also like put it in a single line like this. Say, if name is equals Kemi, print my name is Kemi, and you want to also print other things like print I am pretty. You can do that. Like you can just do that, but you have to make sure that if they're going to be on the same line, you have to make sure that there is a semicolon that is separating each of the statements. So you can have as many statements as you want here. You can have as many statements as you want. But then somebody looking at your code might just be like, this is and it might just look messy in the person's eyes and you might not really understand what's going on. So it's much more preferable. I think it's like the preferred thing to do, to just have, if you are not having just one single statement after your if expression, you can just put the remaining statements inside blocks. But then this is still possible in Python. Okay. So I would like to ask a question. Let me see what's called. Okay. So let me call on Emmanuel. So if you look at the code I just wrote, Emmanuel, are you there first?
Yes.
Is Emmanuel there? Okay. Yeah. Okay. Cool. So let's say you are looking at this line of code now. Like, what does this if statement interpret to? What does this if statement interpret to?
Okay, so I said if the variable that's the name variable there is equal to Kemi, then print these three statements. The first one, my name is Kemi. The second one, I am pretty dot.
Okay, so could we say that if the expression doesn't evaluate to true, then the rest of the statements will still be printed?
No,
Can
nothing
we
true.
say that?
Not constant.
Okay. Okay, so that's correct. If the first expression doesn't evaluate to true, the remaining statement will not print. So it's still the same thing like this is the entire block. So if this does not evaluate to true, it will not print. Okay, so that's that. Okay, so we also have something called a ternary operator in Python. So ternary operators are like they don't really like they don't help with control flow per se. Like, okay, if a particular value is true, then do this. What they just do is like they help you to know which expression to assign, or let's say to assign to a particular variable, for example. So it's like a conditional expression. So let's say we have this is the syntax. So let me just the syntax is we have the expression, the first expression, then you have the if keyword, then you have your conditional here, then else, and then you have expression 1, expression 2. Okay, so now we have this conditional is what is going to be evaluated first. So just like in a normal if statement. So if this conditional is evaluates to true, this expression is going to be, this is the expression that we're going to use. But if it doesn't, then we'll use the expression on the right hand side. So something like okay, let me say name is equal to Kemi. Can say, let me say the name is equal to Kemi if this one. Just leave that here. So name is equal to Kemi if let me say if we have a surname here. Okay, so if surname is equal to something like this. So this conditional here is going to execute first. This conditional is going to execute first. So it's going to check if surname is equal to Ibobi. And then if it returns true, if it is evaluated to true, then this expression here will be assigned to name. And then if not, it's going to be given this value funke. So let's try that out and see what is inside of name. Okay, so that's how that works. So then we can also like chain them together. So you can use them if you want to, let's say you want to assign a value based on a particular expression, or sorry, based on a particular condition. Then you can use this. I'm sure like some of you must have come across this in JavaScript also. So this is like how Python does their own. So we can also do a chained conditional expression, like okay, okay, so I'm going to okay. So if you want to chain them like this, you have to put them inside brackets. You have to put the condition inside brackets. else. And you can just go on and on. And let's just say else. Damn. Doesn't really matter. Okay, so let's see what this evaluates. Okay. I think I was wrapping them in the wrong one. Do not close these braces. Okay. Presence. Okay, sorry, this is wrong. Okay. Okay, watch out for the braces, please. So you have to put the conditions inside of braces like this, and then wrap the whole expression inside of braces. So I think that's that. So you can have like as many as possible, and then if you change the value you are evaluating against, it just assigns this to name. I don't know if that's clear, but this is how you like chain conditional expressions together. Is that clear? Is that clear, guys?
Yes.
Hello? Okay. So there are times when you don't want to do anything. Say, let's say you don't really want to do anything if a particular let's say if a particular condition evaluates true, you don't want to do anything, or even if it evaluates false, you don't want to just do anything. You can use a particular keyword. Does anybody know what that keyword is? So I say I want to do something like if surname is equal to Nnamdi. I don't want to don't do anything. Do you know what we can write here? What keyword we can use to tell Python that we do not want to do anything? Does anybody know?
Yes. It's the pass
what's
keyword.
That keyword?
The pass keyword.
Okay.
Yeah.
So if you do that, then Python is not going to like shout at you or anything. So it just goes like that, like it doesn't disturb you. So it's like a placeholder to just like give the interpreter something to be happy with until maybe you decide what you really want to do inside of that statement. So you can use them, you can use it inside, you can also use it inside of the function if you do not want to maybe you do not want to do anything yet. You just want to have a placeholder. So that's that. So not yet. Let's just first go to loops first. Let's go into loops. So I know done some things with loops before, like we've looped through a list, dictionaries, and loops and dictionaries. So loops are also like, loops help you to like iterate over a sequence. So yeah, they help you iterate over a sequence. So it could be a range of numbers, it could be a list, it could be a string, or let's say dictionary key mapping. So there are two types of loops in Python. We already know the for loop. Does anybody know the second type of loop? Imala, do you know? Does anybody know the second type of loop in Python?
The while loop.
Yeah, the while loop. Okay, so let's just go refresh our memories again and just look at the for loop. So let's say for number in range 4 number. So this is like the basics, the syntax of the for loop. So it goes and prints from 0 to 3. So we've used these ones before, and like I'm sure everybody's comfortable with using for loops. Yeah. Am I speaking your mind? Are you guys comfortable with using for loops already?
Yes, I am.
Yes, we're
Okay.
comfortable for
Yes. Okay. So like, what did you say? Okay, I'm seeing your charts. Yeah, I was not looking at that. Okay, so now while loops are like, they run as long as a particular value evaluates true. So let's say, let me just say count is equal to 0. And I want to create a while loop that will print out something, or print out this count value, the value of count, as long as count is less than 5 or 10. So you start with the while keyword, then you put in your expression. So let's say count less than 10. Less than 10. What's going on? 1 0. Okay. So I want you to print count 0, 20, and then I want you to increase count. So, Imole, do you know what this expression means? Or should I say statement? Do you know what this statement means?
Yes.
What does it mean?
Increment by 1. Like the count will increase by 1. Once it prints 1 count, then the count will go to 2. Then it will be plus 1 like that. It gets to, since y count is less than 10, then it will now stop getting to 9. But it's actually just 0 to 9.
Okay, so I'm asking for this one, this particular one I'm highlighting. What does this mean?
For that one, it simply means count is equal to count plus 1.
Okay, yes, that's correct. So, Imole, I'm sure that's what you wanted to say. So that's correct. So, let's do that. See, yeah. So let's run this. So as long as count is less than 10, it will print count, and then it will increment count afterwards. So why does it not print up to 10? Why does it not print up to 10? Who knows why it doesn't print up to 10? Because I want to print from 0 to 10. Imole, please.
Count is
it's not printing up to 10 because we've told it that y count is less than 10. So if it's that we added less or equal to it, will go up to 10. But because we've indicated in our condition that while count is less than 10, that is when that expression should be carried out.
Okay.
So it will stop at 9.
Yeah, so by the time we get to let's say by the time count becomes 9 and it prints out 9, and then you say count plus equal to 1, count will become 10, and then 10 is not less than 10. But you are correct. If you say less than or equal to, then it's a print up to 10. So that's so this is how to use a while, how to create a while loop. So you start with a while keyword, you write out the expression you want to evaluate, and then your statements. You can write as many statements as you want inside of this block. So make sure you indent your block, the block you are writing your while block, so that whatever statements you want to write will be inside of there. Yeah, we'll evaluate, and we will execute. So there's also like this break, let me say break keyword. So the break keyword, we use it when you want to get out of a loop, like exit a particular loop. So let's say I want to stop printing when, count is equal to 5. We can now do something like if count is equal to 5, then stop the loop. Excuse me. Okay, so when count becomes 5, you see that the loop just exits the loop. So if you want to, let's say you are looping through a value, let's say you are looping through a list, and you're like, okay, once the value of the list or the element is equal to, let's say you're looping through a list of colors, and then you say, okay, once the element is equal to color yellow, I want the loop to stop. So you now do something like if color, then the index of that, let's say the index of the particular counter, I don't know. Yeah, so the index of the counter. So if it is equal to yellow, then stop, exit the loop. So that will just happen. But what if you have like a couple of statements you want to execute every time? Okay, Imole. Somebody was raising. Imole, you were raising your hand.
I didn't lower it the other time.
Okay. So what if you want to like you have a couple of statements inside of your while block, your while statement, and when you've looked through your sequence, and then you have, let's say you get to a value, and when you have that particular value, you do not want the rest of the code in your while loop to execute. Do you know what you can do? I don't know if I'm asking the question right. So let's say you have
okay, I think I understand your question. You use the continue statement.
Yes, that's correct. So you use the continue statement. So let's try this and see what it looks like inside of here. Okay, it actually just skips the current block. Okay. Okay, this actually works if you have like two loops going side by side. Let me see if I wrote something for that. Okay, but then that's what you actually do if you want it to skip if you wanted to skip the current block of code, you just use the continue. You continue. Okay. So let's say we want to print out odd numbers from 0 to 10. Let's say we want to, okay, let's do that. Let's say we want to print out odd numbers from 0 to 10. And okay. Okay, odd numbers. So let's say we want to print out odd numbers from 0 to 10. What can we do? We can do something like,
Use modulus.
what did you say?
We use the modulus. So like we tweak it around the modulus. If the number is not a modulus of, I don't know, if the modulus is not equals to 0, it should not count it, something around that.
Yeah, so I wanted us to take the exercise, but I think I'm going to give you another exercise then. So let's say we want to print out odd numbers from 1 to 10. So we can just do something like if x is equal to 0. So yeah, this is like where it shines. Else just print x. So like, okay. So like, where's my run code again?
I think something is running already. I think you need to stop a particular process.
I'll stop and again. Okay. So here now, if x%2 is equal to 0, it just like skips this particular block and then keeps running your loop. Yeah, that's like where continue shines. So I think that's that. So what we can do now is we can, before I show you something inside of loops, I think we should do a small exercise. So I would like for you guys to create a list on your laptop, or if you do not have a laptop, you can type inside of the chat. So I want you to create a list of like your favorite places. Are you guys on?
What are you writing, please?
I said you should create a list of your favorite places.
Oh, okay. He says you're not okay.
Favorite places.
Does it has a range? Like how many?
You can have as many as possible. Let's say 5 of them. Please just give me a second. I'm still here. Okay, so can I see your list now that you're done? If you're done with your list of favorite places, can you submit into the chat? Let me see. Can you guys, I'm sure you guys can hear me. So can you submit what you've written in your list of favorite places? Okay. There are mostly one person's on. Okay. So now I want you guys to look through this with a for loop and first add Paris to your list and add London to your list. So if your favorite, okay, my typing. So if your favorite place, so if your favorite place is equal to Paris, I'm not finished typing now. If your favorite place is equal to Paris, I want you to skip running the if block. Skip running the if block and skip the if block and
I don't understand. Sorry.
okay, I'm coming. Okay. I don't know Okay, so if you already have like a list of your favorite places, you should add Paris and London to the list. Add Paris and London to the end of the list. So I want you to print out the names of your cities, format it nicely, format your favorite places. But if the name is equal to Paris, then skip that particular loop and print out the other cities. Is this clear enough instruction? So the first thing, add the 2 cities to your name, to your list. Have you guys added them? Have you guys added them?
Yeah, I'm adding them.
So if your favorite place is equal to Paris, then I want you to skip the remaining, skip the execution of the remaining code and continue printing out the names of your cities.
It's giving me error. I don't know.
Okay. So who else has finished doing their own? Did
Yes.
you write something? Okay.
Yes, I wrote something.
Did you submit it inside? Did you submit it inside of here?
No. Let me submit. It's generating error. I don't know where I'm making the mistake. Let me just copy and paste.
Okay. So now when I run what is inside of, okay, let me use your own code. Stay there. Has everybody dropped theirs? London is not defined. So you did not add um quotation marks around your string. Because London is not, you say London is not defined because London is not a variable. You did not define it. So you have to put quotation marks around. Favorite places is not defined. So you use favorite places or fav places. Okay. Okay, so now you see that
Yes, I saw my error.
yeah, it keeps this item or this element inside of the list. But what if we want it to stop printing when it says London? What do we do? Can you put London in the middle of your list? I want it to stop looping when it sees London. How do we do that? Okay, so now you see that a loop can complete. Well, so like a loop can complete execution when a break statement is, so just to this, when a break statement is introduced, or let's say so yeah, when a break statement is introduced, a loop can complete. And let's say you are looking for something. Let's say you are looking for something inside of a loop. Let's say you are looking for something that does not exist, like Lagos. Lagos is there. Benin. So we're looking for something inside. Okay. Please. Okay. So let's say we're looking for, let's say we're looking for a place called Benin inside of the list. And then it doesn't, that particular item is not in the list. You can see that your loop will still complete. It will complete the loop just as let's say just the same way a break statement will also complete a loop. Do you guys? So it's either the loop, your loop completes on its own, like if, let's say, if the value you are looking for is there, the loop completes. Oh, okay, yeah, it still completes because it runs it through. And then if it is not, if your value is not, let's say the item you're looking for is not there, your loop still runs. So how do we know if a loop, how do we know if your loop is completing? Because let me say, how do we know your loop is completing because it did not find the value that you asked it to search for, compared to, let's say, when it is completed by a break statement? How do we differentiate those scenarios? So let's say I want to know I want to know if it is because my loop cannot find Benin inside the list of these cities. That is why it is completing. How do we know? How will we know? Who knows how we can tell that? Does anybody know?
I
It is
didn't
something
get a
called
question.
nesting.
Okay, so now there are two scenarios. Our loop can just like complete. When I complete, it just maybe ends, it stops running or it completes running. So if let's say we have if fifth place equals to Paris, I want this loop to break. So it completes like this because it exits the loop. This is one scenario. This is another scenario when you try to look for an item that, let's say you're trying to look for an item that does not exist. You see, your loop still exists. So how do we differentiate between when a loop is existing because it did not find a value or because of a break? I don't know if you guys understand what I'm trying to say, but
You're asking how do we know when the loop is exited because it could not find a value, right?
yes. How do we know it exited because it could not find the value or because it found an item and then it encounters a break? So you can tell your loop that, okay, if you see an item, I want you to break out of this loop. But then we will not be able to know if it is because of the break or it is because we did not, on the other hand, in the other scenario, if we did not see the item we're looking for. So how can we differentiate? How can we know? Not in keyword. Well, not exactly, because I can also put in a value that is not inside. I can put a value that is not inside of this. This is just for, if I'm saying for fifth place in fifth places. Wait, what do you mean by not in first? Let me understand what you're saying. Do you mean for fifth place, not in fifth places, or what?
Not in.
Emmanuel,
Yeah, I was saying you could on that block of on that line 4 where you have third place is Benin. You can write if Benin not in few places, then print execute the print place code, something like that.
okay, if Benin not in
Third places.
not in fifth places,
Yeah.
what should I print?
If you print fifth place, it will not print everything inside the list.
So what if I have like plenty conditions? It's not just Benin.
Nothing.
You use the variable in the for loop. If that variable in the for loop is not in favorite places, then you print that or you do something.
No, I want to know the reason my loop is not completing. I'm not trying to check for, I'm not
Okay.
interested in checking for if Benin is, I want to know why my loop is existing. Is it because I can have like two statements now? I can have this and I can have if then break. What if I don't want to print? Say I'm not printing anything to let me know. And I'm having if Benin, if Paris. But I don't want to print, I want to pass. So what if, how do I know?
Okay.
How do I know if you see that my loop exits?
Yeah.
So how can I do that?
Try.
Okay, so unlike in other
Can I use for
other
else?
languages, yeah, definitely. So unlike other languages where you cannot use for with else, you can use for else in Python. So let's say else not found. So let's do this first. So this is the first one. This is the first conditional running. You get? So if you try to, in most cases, this is like the scenario. So you're trying to find something and then the item or the element doesn't exist, then you would be able to know if your loop did not find that item or that element if you use an else clause. So, but otherwise you will not know because it's just going to exist, and you might be thinking, oh, is it the second one that caused it, or is it the first one? So you don't really know why your loop exited. So this is like the way to do it. So if your loop executes normally, like if your, what am I trying to say? If your loop does not encounter a break statement before, let me say it does not encounter a break statement. So let me remove this now. I'm still like doing if. How do I do this? Okay, this is an if. So let's say, let me remove this. This is going to like, let me see how to. So, okay, let me say if a place is equal to Lagos, and let's break. So if your for loop does not encounter a break statement, then this else is going to run. That's if something like I'm trying to find an item and then the item is not there. So this else is going to be executed only if it does not encounter a break statement first before seeing this. So like once you've broken out of your loop, you've broken out already. You get? Does that make sense?
Yes, it makes perfect sense. I didn't exactly understand your question. That's why I wasn't able to come up with the foils. But it makes perfect sense, yes.
Okay.
For me.
So like that's how you can, those are like scenarios. There's some scenarios you might just find this very useful. Yeah. So that's that for loops and conditional.
Sorry, one more thing.
Yes.
If that breaks, can you Ctrl Z?
Okay.
Okay, but if this break states if
this is a continue.
All right, I get you.
To run. Yeah, if it's a continue.
To run. And the break would, yeah,
but
perfect,
the break is saying get out of my loop. Yeah, exit the loop. Yeah.
All right.
Okay. So I don't know if you guys have questions. Do you guys have questions before we move forward? Okay. We'll be looking at functions like we're looking at functions. So all of you have seen like samples of Python, like built-in Python function. We've used Python built-in function. I've built-in Python functions here before. So if you know anyone, just type it inside of the chat box. Let me see. Type the ones you know. Learn, yes. So this is a function. See. No, there's a difference between function and method. So, well, it's still the same concept. So, yeah, please just type them in. Yeah, so to remove. Okay. So all of these things are like built-in Python functions. You've all made use of functions one way or the other. So all of these built-in functions, they are there somewhere. You don't really need to know exactly how they work. You just need to call them. And you know that, okay, if I put in a string or a list inside of this, then I'm going to get the length of the string or the length of the list. So you don't really need to know, okay, how does Python calculate all of these? And I remember we also used ID. Do you guys remember when we used ID? So you just know, okay, if I put in a, let's say I put in let me say a variable, then Python is just going to return to me this object's unique identifier. So you don't really care how that works. You just tell Python to just call it, and then it does that function for you. It executes accomplishes a particular task for you. So what are those let me see what are those things you need to know for you to make use of built-in Python's built-in functions? What are the things you just need to know if you want to use Python's built-in functions? There are just two things you need to know. What are the two things you need to know? So the first thing you need to know is, does this function accept arguments? So if the function accepts arguments like this is what is an argument, this value, this string you pass into this len function, that is like the argument. So what happens if you do not pass in any arguments? It says type error, len takes exactly one argument, 0 given. So you need to know if that function, takes in an argument, and then you also need to know if it brings back a value. So if you send in 1, 2, 3, 4, 5, 6 to the Python's len function, you are expecting it to return a value to you. That is the length of your string. Yeah. So those are like the things you need to know. So now you're going to be defining your own, you're going to be writing your own Python definitions. So what are functions? Functions are like, a function is a block of code that that accomplishes a specific task or a group of tasks. So let's say before we get to that part, let me just say, when you want to call a function, you basically just say, okay, you call the name of the function, that, so like this function is len, you call it, you write len, and then you pass in the appropriate arguments. You saw that when you do not pass in the appropriate arguments, it threw an error. So then your Python code, like if you call it Python, a function anywhere in your Python code, your Python interpreter will go to where that function is, execute it, and then come back to its caller. So that's just basically what it is. It just goes, when you call a function, your program execution will transfer to that body of code, or the block of statements that make up your function. And when it's done, it returns to the location where your Python function was called. So depending on how you design your functions interface, you can say, okay, I want my function to accept arguments. I want it to return a value, just as we saw in the len function here. So, but then why should we even create functions in the first place? Who knows? Who can tell me one reason why we should create functions? Why can't we just like write all of our statements inside of our main Python? Let's say this is your main.py. Why can't we just write all of our codes straight down inside of this file, or inside of just this main.py? Why should we write functions in the first place? Does anybody know?
Yes,
Just
because it helps us to avoid repetition so that we don't clog our file or our script, having to repeat the same thing over and over again, when we can just make reference to a particular few lines that could keep doing the same thing for us.
Great. So that's the same thing with what Emmanuel is saying. It says functions stop the repetitive use of a particular code. So say you are writing let's say a function for accounting purposes, and then you want to sum values every time in your code. So one thing you can do is you can write your Python statements to sum the value. So let's say sum, assuming there's no sum function in Python. So you can write your sum. Okay, just hashtag this. So you can just write your sum statements here, and there are going to be like many of them. Let's just say 10 lines of this code. So you want to sum statements here. These 7 lines of code are going to sum, let's say, a particular number of some numbers. So let's say in another part of your code again, you want to now sum, you want to also add values. You can still say, okay, let me copy all of these and paste them inside of that file, or inside of the code. And then you can keep doing that every time you want to sum values. Yeah. Or you can just write a Python function, and then anytime you need to sum, you just say, hey, sum, and then sum just comes and sums everything up for you. So why that makes sense, why this makes sense is that when you want to, let's say you want to adjust something in your sum, let's say you want to adjust something in your sum, then you have to go and look for all of those locations where you pasted your sum statements, and then you start adjusting them one by one, which like doesn't make sense. So number one is reusability of code. You can instead of replicating your code over and over again, like you guys said, you can just write it somewhere and then call it anytime. And anytime that code needs to be modified, you don't have to start looking around for all of the places where you wrote it. You just need to go inside of your code and then adjust it. So anytime that code is called, like anytime you call that particular function, it just does whatever things you've added to it. So another thing is abstraction. So right now, like we said here, you don't need to know what is involved in creating. Let's say you want to do the max. What's this? Max thing. Let's say you want to find the biggest value in 23, 45, and 6. You don't need to know how does max work. Like, I mean, Python takes care of all of that. So you don't need to say, okay, how does this work? It's abstracted. So basically, you just have to call it. So in your own code too, you don't really need to start wondering, especially because you're going to be working with people. So you don't really need to know, okay, what exactly does this involve? You just know that, okay, if I pass in a particular value, let's say a particular task is going to be accomplished, or I'm going to receive a value back. And then it also helps you so functions also help you to make your code modular. So you do not want to, because when you start writing plenty codes, you can start writing so many lines of code, and it might be hard for you to it might become very complicated at a point. So thinking about managing your code, let's say thinking about let's say you have so many tasks. Let's say you have a very big task, and then you just have all of the code to solve that very large task inside one single block like that. So when you have a particular problem, it's hard to pinpoint where that problem is coming from, because like you can just see all of this large code, and then you don't know where to start troubleshooting from, or you don't know how to start fixing that problem, or how to start managing your code. So, but then when you now break them into smaller tasks, like smaller functions, so let's say you have to, let's say you have a big task of writing files, reading and writing files. You can just break them down into, let's say, reading, writing, and processing files. So you can just break them down into smaller codes, so that if any problem comes or occurs when you are trying to read file, you know that, okay, my read function is what is handling read file. So if there's any problem that has to do with reading a file, you just go straight to your read file function. And then if let's say you have a problem, or you're encountering a problem writing a particular file, you just know, okay, it's inside of this my write file or my write function. So with functions, you are better able to manage your codes, so that it does not become too complex for you to like wrap your head around it. Yeah. So another thing is, there are times when you want to use a particular identifier to name. You want to use a particular identifier to name something like distance, or any identifier. It might have different meanings in different settings. So if you just inside of your main code, you just put identifiers equal this, and maybe later on you want to use distance equal this, and later on you want to use that same identifier to store a particular variable, or to store a particular value instead of you might start having your values can start like colliding, or you might just start making mistakes, because distance might be referring to another variable that you wanted to store for something else. So instead of like trying to thinking about how to manage that, you can just put them inside of a function. So anytime a function is created, every time if a function is created or called, a new namespace is created. So the namespace is just like the textual region in which an identifier is meaningful. So let me say, so let's say just, so so inside of here now, you can say maximum is equal to 23. And then inside of here, I can also say maximum is equal to 34 or 345. So this is kind of, when you call this particular function, like the variables you declare here do not interfere with those in another function or even in the global namespace. So it helps to prevent collision or interference with variables of the same name that maybe you want to reuse the identifier in different parts of your code. So if you just put in the function, it creates a different namespace. And so there's like a different, no, let me not go there. So I think those are like the main reasons why you would want to use functions. So, and then you can we talked about the smaller managing larger tasks already. So okay, so when you want to define a function, you have something like, when you want to define a function, you use the def keyword. Use the def keyword, and then you write the name of your function with brackets, and then you put in your semicolon, and then you indent, and then you put in all of these statements you want to put inside of your functions. So let me remove this one. Okay. So let's look at this together. So when you write def like this, you're simply telling Python that I want to create a function, or I want to define a function. And then you have to put in, we talked about identifiers, so it still goes for function names. When you want to name functions, you should also use a valid Python identifier. Then inside of these braces, inside of these brackets, you can put in parameters, or you can put in no parameter at all. So it's optional. If you want to put in a parameter, you just say, you can put in as many parameters as you want. You can put latitude, longitude, for example, and then you separate them with commas. And then this semicolon is simply saying, okay, this is the end of my Python header, like the function header, and then we're going to be starting a new, the next thing you're going to be seeing are like the function block, So if you now want to call your, what do you call this? You want to call your function, you do this, just call the function name, test, then you now pass in what is called an argument. So the arguments are simply the values that you pass into a function. They usually correspond with the parameters that were defined in the Python function, in the Python function definition. So here now you see we have one parameter for latitude, and we have another one for longitude. So when you are calling your test, you have to put in arguments that correspond to the two the two parameters that were created when we're defining our Python function. So let's say 23 point yada yada yada, and this point, this. Okay, so what this means is this value now is going to be for latitude, and this value now is going to be for longitude. So when you're passing arguments, it's like you're telling Python that, okay, I want to create, let me see. So when you're passing functions, it's like when you're passing arguments, I mean, it's like you're saying, okay, I'm creating like a variable for latitude. So it's more like saying latitude is equal to 23.0999 and longitude is equal to 546. This. So that's like creating a variable, basically. Now, even if you are calling a function and it does not have what do you call it? It does not have arguments. It does not have parameters. You cannot just call the function like this. You still have to put your brackets inside outside of after the name after the function name. So you can't just say test and it won't work. So you have to put your brackets. Okay, so yeah. So in this case now, when let's say we put lat and longe, we have 23 and 45. So when we do this means when we are passing arguments like this, you are passing in positional arguments. It means that the order in which the arguments are passed is the order in which it's going to be, the variables are going to be assigned. So you are saying 23 should be for lat and 45 should be for long. If you want 45 to be for lat, and you want 23 to be for long, you have to say it like this. So you cannot just expect Python to know what is on your mind. So this is like, you have to, based on the position, or let's say the order in which you pass it, that is exactly how it is going to be passed. However, you can also pass arguments like you by specifying which argument you want to pass. Okay, let me see. Okay. So yeah, like I was saying, you can actually just if you are the one that is like creating the function, it is easy for you to know to know in which order the argument should be passed. But sometimes it can be confusing. So you can explicitly say, okay, I want this value to be for longitude, I want this value to be for latitude, in any order. So if you want to do that, you have to say it explicitly like this, just like this. So there is no confusion here as to which argument is supposed to be for which parameter. You can also do this if there is even an extra, I don't know which other one, let me just say extra. If there's an extra value, you can just do this. Extra is equal to 4.5. So you can even put this one here, and then there's no problem as to the order in which the arguments are passed. So that's like keyword arguments. So yeah, so it's flexible because you do not need to say, okay, you don't need to specify the order in which the arguments are going to be passed. So unlike in positional arguments. So if say we want to, let's say we do not know which, let's say we do not specify certain parameters. Let's say we do not specify certain parameters, like say I don't specify lat, and I want to, yeah, let's say I don't want to print anything. So if you do not specify a particular argument, or a particular argument, and your function is expecting that one, what happens? Does anybody know what will happen if you do not specify a particular let's say you don't specify a particular argument. Does anybody know what will happen?
Okay, like this function you just
Does
stated now,
anybody,
like if we don't pass an argument,
let's say we do not pass one argument out of all the parameters that were defined, what will happen?
if the argument doesn't have a default value, Python would throw a what's it called, argument error, raise an argument error.
Okay, what does that look like? Okay, so it says, thank you. I think that's meant so. So it's going to say your test function is missing one required positional argument lat. So that will need to be specified. So, but what you can do is you can if you let's say you are expecting that, let's say you are not expecting all of the parameters that you defined, and some of them, like even if all of them is not let's say all of them are not given or provided, you can still perform the computations you want to perform. So in that case, you can just put in a default like lat is equal to 0. So that means that if you do not specify lat, then the default value is going to be 0. So like that's a default parameter. So then let me see. Okay. So actually it should be it's positional before keywords. So if you are going to be having a mix of keyword, or should I say default parameters, the default parameter should be at the right hand side. It should not be at the left hand side of a positional parameter. But then it doesn't matter if you give all of them default values. So even if you do not pass in latitude, your latitude is just going to be 0 in this case. I hope that makes sense. Okay, so we've talked about optional parameters, and okay. So like where there's a drawback with optional parameters, I guess, is that it behaves funny. It behaves in a funny way when you use it with data types are mutable. So let's say we have who can tell me one mutable data type? Excuse me. Can tell me one mutable data type? Okay, list. So let's say we are expecting a list. We're expecting a list when test is called. And you now say, okay, if the list is not passed, I just want you to say that my list is equal to, I just want you to give it a default value of an empty list, like, okay, like this. So even if you do not pass in your list, that's the list argument, then Python is then you want your function to just give it a default value of an empty list. And then what you want to do is you want to say my list dot append hello. So does this make sense? Hello? Does this make sense? Yes, it does. Yeah, it does. So it does make sense until some unexpected things start to happen. So let's print out, let's return, I'll come back to return later, but let's return my list dot append hello. So let's print out this. What was this now? Okay, you know what? Let's just say, let's do my list dot append hello. and let's print my list. Okay, sorry, you don't have to print anything again. Let's just run it. So you see that because you do not specify anything, it just adds the hello element inside of my list. But this is where it starts becoming funny, when you start saying calling tests. Normally you should be able to just plug and play, like call your function and it starts from scratch, like, and just runs your code. But when you do this, you start seeing that hello is like appended every time. Do you guys know why? Do you guys know why this happens?
No.
Okay, so usually okay, Emmanuel, you said you know why. Can you say why?
All right, it calls the function. The function was called 3 times. So for each time the function is called, hello was appended to the list.
Okay, but then you do not remember that we said that when you call my function, my list should be an empty list. Do you remember we said that? If it is not specified, then my list should be an empty list. So I expect that if I call test again, then my list should start with like an empty list and then append just one hello. So it should not like be giving me different results. Okay, so usually what happens is when you define when you add a default parameter inside of your Python definition, what happens is at the point of creation is when the default parameter is going to be defined. It is defined only once. Each time you call your function, it doesn't get defined again. It is just defined once at the point where the function is defined. So if you, let me see, can we print out? Let me see if I can print out ID of my list. So do you see that every time a function is called, the ID of the list is still the same? So it means that it is just defined once. It doesn't get redefined at execution. So that is what happens. This is like the drawback when you are using mutable data types in default parameters. So it doesn't have any problem with like your other immutable data types, but when you start using it like this, you start having issues. So what you can do is you can just use let's say you can use a value that you know that, okay, even if it is redefined, like it doesn't change anything. So what do you think we can use? Which value do you think we can use that even if anything happens, like it doesn't affect it? What value do you think we can use? So we can just say my list is equal to none. That's like what people use most times. So just say my list is equal to none, and then you just say if my list is none, then let's just create an empty list. So then inside of your commands, like whatever is inside of your definitions, the statements inside your definition is going to be run again and again and again. You get? So then you can now say, okay, I want to append this to my list like that. I hope that makes sense. Okay. Do you guys understand what I just said? Okay.
Please read.
All right. So I should go back again.
Yes, please.
Okay. So I said that when you're using mutable data types, you start having some funny you start getting some funny results. So this my list here, like I explained before, when you write a default parameter like this, if you write a default parameter like this inside of your Python definition, it is only created, the variable is only created at the point that it was defined. So when you call it again, it will still reference the definition, or it will still reference that variable. I don't know if that makes sense. So if you call it again, if you call that, okay, let me see how I'll say this. So if you use, let's say, a list inside of your default parameter, your list is only defined once. If you call this test function again, my list will not be redefined. So it's different from, it will not be redefined again. It's not going to say my list is equal to, it's not going to say my list is equal to an empty list again. It's going to go back to the reference where it was defined. And where it was defined is inside of this container here. Or should I say inside of this? This is the value of where it is in memory. Let's say that. So it just goes here, references this value or this ID. And then when it references it sees that you've already appended, it just picks it like that. And if you run the function again, it kind of like just appends. If you say it should append another hello, it just appends it to what was formerly there. So every time every time you call test and you tell test to append hello, test is going to go and bring your list, which you've called it 3 times already. So it has appended hello 3 times. So it will bring that same list and then append another hello. It doesn't create another list from scratch again. Do you get what I mean? So what you can do is you can just assign, if you do not want to have this kind of error, you just give your list a value of none. So if let's say if you do not pass in, let's say you do not pass in any argument into your test function, then automatically your list is going to be assigned to none. And then you can now say, okay, if list is none, then I want you to create a new list. So that's going to create another list. And every time you call that function, a new list is going to be created or defined. I don't know if that makes sense. Does that make sense?
Yes.
Okay. Yeah. So I don't know if we've not talked about the return statement. So I don't know if we don't have the time for that for today. So, but it's not much. What return does, okay, I think that's she's almost 3. Okay. So I think like okay. So we've talked about some things about functions. So next time I think we will just talk about the return statements and how to return data. Then when you want to pass in arguments and you don't at the point of creating the function, you do not know how many arguments you want to pass. So we'll learn about argument tuple packing and argument tuple unpacking next. That's tomorrow. Yeah. So this is like what we'll just stop here. So I want you guys to write not now, just okay, yeah. All right. So yeah, let's just stop here. So tomorrow we'll continue. If you guys have questions, you guys should let me know. Thank you too. Do you guys have questions?
Yeah, okay.
Daniel.
So I think someone has a question.
Yeah, Daniel, go ahead.
Okay. Please, this my list that you say is not, because from what you said that the function is a local variable and anything outside it is global. That anything that you do in the function does not affect the global variable. So from this calling, my list is equal to none. I thought this my list is a global variable. Then why is it that when you call it, the global variable now changes to?
Okay, so my list is not a global variable. It is created when you define the function. So it is inside of, you can see it is inside of this, inside of the function definition that I am changing what is inside my list. Do you see? So I'm not like changing, there is no my list defined outside of this function. It's only defined inside of here. So because this is a default parameter, like I said, it's an optional parameter. So it is, if I do my list equal this, then I'm saying that as I'm defining this list now, my list is going to be defined as this. And it's not going to be defined one time. So anytime I call this function, it doesn't like redeclare my list to be an empty list again. So everything that is going to be done to this list now is inside of this my function here. I've not done anything outside to this list outside of this function, have I?
No.
Okay, so everything is inside of this function now. You get? So I'm calling, this is my main Python code. So I'm calling the test function from outside. I cannot call the function from inside because I did not declare the function inside of test. I defined it here, so I have to call it here. I have to come outside of the function and call it. I don't know if that answers your question.
Yes, thank you.
Okay. Okay, does anybody have another question? Okay. So if you don't have any other questions, we'll meet tomorrow to complete this and to complete our class and go on to the next. Okay. Go on to the next class. So sorry for taking your time because it's already 14:58. So should have been done a few minutes ago.
Okay, so yeah, so thank you, Carrie. Thank you for the class. Yeah, and to every other one person, thank you very much. So we'll meet tomorrow for our next class. Okay, so thank you and have a wonderful day.